What is a differential equation? This is a differential equation, which is called an equation because it contains one or more unknowns. And as we have already seen in algebraic equations, like this one, the unknown is a number obtained by solving for x, which is the number that solves the equation. So, what is the unknown in a differential equation? To answer this question, we must look at the difference between these two types of equations. Both have letters and numbers. But the differential equation has an apostrophe that the algebraic equation does not. That apostrophe is the derivative, meaning a differential equation is an equation that contains derivatives. And that is why it is called differential. Be careful, theoretically, differential and derivative are not the same. And even though the idea of this lesson is not to explore that difference, it is important to remember that for a differential to exist, a derivative must exist. Now, we must remember that the derivative only applies to functions. Therefore, if you know that this apostrophe represents the derivative, and the derivative only applies to functions, then this letter definitely represents a function. And it is that function that is the unknown in a differential equation. In other words, the unknown or the objective of a differential equation is to find a function that solves the equation. Now, if we are going to talk about functions, then we must recall the basic elements of a function, since by the mere fact that one exists, there will necessarily be constants and two types of variables: the independent variable and the dependent variable of the function, elements that will also be present in a differential equation. The constants are numbers or letters, which we will soon learn how to identify and differentiate from the variables. The independent variable is the one that can take any value it wants, as long as it is within the domain of the function. But that is another topic, and it is also what causes the dependent variable to change its value. Therefore, the dependent variable is the variable that depends on the value of the independent variable, and it is the letter that represents the function. For example, if you have the function f of x equals x cubed minus x, you should remember that the letter inside the parentheses is the independent variable, meaning x is that variable, and f of x is the dependent variable, which for convenience is often written as y. As you can see, y, the dependent variable, depends on the values taken by x, the independent variable. If we apply this to a differential equation, we have already seen that the apostrophe is the derivative. Therefore, this y is the unknown and represents the dependent variable, which is the same as the function to be found. Consequently, this x is the independent variable of that function, and the numbers are constants. What is important here? It is to realize that all the elements that may appear in a differential equation are part of its solution. And if you do not believe me, I will give you the solution to the given equation, which is this, where we see the dependent variable, the independent variable, and some constants. Therefore, having seen all this, we can define a differential equation as an equation that relates a function with its derivatives and its variables, and its goal is to find that function. In summary of the lesson, just like an algebraic equation, a differential equation contains unknowns. In addition, a DE is composed of derivatives and therefore involves functions. And since there are functions, there are also independent variables, dependent variables, and constants. It includes all of these because the objective of a DE is to find functions. Consequently, we define a DE as an equation that relates functions with their derivatives, their variables, and their constants. I now invite you to work on the exercises for this lesson so you can practice what you have learned and firmly grasp the concepts.